Hey everybody, so we've talked about derivatives, so now we're going to go to antiderivatives. Now with antiderivatives, if you think of the word anti, it means against, or pretty much not the same thing, or the opposite really of the thing behind it. So in other words, antiderivative is the opposite of the derivative. So here, when we talk about the opposite derivative, that means we're given the derivative and we're going to move backwards to find the original function. So they gave us, for example, let's say f prime of x, and we need to find f of x, capital F. So antiderivatives will be considered your capital F, and you know that the f prime of x is your derivative. We talked about that already. So here, we're going to be finding our f, capital F of x, the antiderivative. Now, when you see in a few seconds here, they write down the notation of f of x for your derivative. And then they want you to know that that just means that your derivative is f prime of x that's originally given to you, and you're finding this. So, and 9 times out of 10 from the work that they give us, it's in your book and everything, they're going to have you actually, they're going to give you the f of x, and they want you to find the capital F of x. So in other words, they still give you derivative, but they don't tell you that it's necessarily derivative. But yeah, so they just want you to know that that's what that means. All right, so when it comes to our antiderivative, we're going to start off with our rules here. And here, the first one is the power rule. Now, with our original derivative, means we said that we would take the exponent, move it down, and subtract 1 from the exponent. But this time, we're trying to go backwards to the original function. So what we're going to do here for our capital F, antiderivative, if we were subtracting 1, we're going to add 1 here. So, sorry, we do x n plus 1. And for the derivative, we brought the n down, so it means it was n times x. But we're going to do the opposite of that, so it means we're going to divide by the new exponent. So we're going to add 1 to the exponent and divide by that new exponent. So I'm going to write that down. So add 1 to the exponent. And then we're going to divide by the new exponent. Okay. Now, the only other thing that I'm going to put up here is that after you find the antiderivative, every time you must put a plus c. It's plus c. Now, with it, sometimes you will see they won't have the plus c because they actually give you other stuff to be able to find out what c is. But we're going to do plus c because, and I'll explain it when we get to the actual example. I'll explain where that plus c comes from. I'll explain it more there. But for antiderivatives, we're always going to do a plus c on the end of it. Always. All right, for our constant multiple rule, again, we're going to add 1 to the exponent, and we're going to divide by the new exponent, and then add plus c. So here, we add 1, and we divide by the new exponent, and then we just add plus c. That's all. So we add 1 to the exponent and divide by the new exponent. So it goes, remember, it goes backwards of what the derivative did. So if we subtracted 1, we're adding. If we multiplied, we're going to divide. Okay? The sum rule is even easier. So all you do is find the antiderivative of the f and the g functions, and then add them up, and then plus c. So capital H of x is capital F of x plus capital G of x plus c. Right? Which means that our difference rule does the same thing except for just subtraction in the middle. So take that, and put a subtraction in the middle, and plus c. Bam! That's all. And again, when it comes to the next example, example 2, I'm going to show you how to find that plus c. And yeah, that's it. Now, one thing I will do in that next video, I actually did say that I left off the plus C, because the original video for the rules, I left off the plus C, but it's there now. So when you see it in the notes, you'll be like, oh yeah, that's what he's talking about. Like we needed. That's why we did this stuff. Blah, blah, blah. Yeah, so it's gonna be good. But these are rules. Remember them, know them, along with the derivative rules. Know them, know them. Don't know about them, know.